Let's continue talking about fundamentals of swine nutrition and nutrient requirements. Let's focus now on growth and nutrient requirements. Before we talk about nutrient requirements, it's important to know the composition of the growth, because the composition of the growth is going to be a determinant of what are the needs of those requirements. And the composition of growth, we can divide it into three big main groups: ash, lean, and fat tissue. Ash is mainly referred to as an indicative of the bone structure of the pigs. And as we can see, as the pig is growing, obviously the skeletal system is growing with the pig, and then it again eventually gets to a point where it starts to slow down once it reaches a certain mature state. In the case of lean, as we increase body weight or age, lean deposition increases and it gets to a point where it starts to diminish eventually. In the case of fat, as most of us know or actually have experienced, there is an unlimited ability to deposit fat in the body. Also, the other thing important to keep in mind here is that these tissues are normally going to be deposited in that order of importance. First, we need to have a good bone structure, then we can put muscle, and then extra nutrients after we put muscle are going to be used to deposit fat. If we look at a little bit more in detail how this process goes, and if we plot here on the x-axis metabolizable energy intake, we can see that as energy intake increases, then the needs of maintenance are going to be fulfilled until we reach those maintenance requirements. And then the extra energy that is consumed above that of maintenance is going to be used first for heat loss of production, and this is basically the heat that is generated by a healthy metabolism or metabolic activities. Then we'll use that energy and therefore the nutrients for protein accretion, and finally the last thing that gets to be fulfilled, it's lipid accretion. And let's remember that when we talk about accretion, we're talking about the balance between synthesis and degradation. So protein accretion is the net result of protein synthesis minus protein degradation, and the same for adipose tissue. Let's talk about methods, and these will be mathematical methods to determine nutrient requirements. Normally speaking, we will come down to a graph like the one that is currently shown, where it has two linear slopes. The first one is a positive slope, and then that means as the pig increases nutrient intake, the response that we're measuring, whether it's average daily gain or feed efficiency, nitrogen deposition, phosphorus, whatever it is, as the pig consumes more and more of that nutrient, we're going to get a greater and greater response until we hit an inflection point, and then that second slope is going to have a slope close to zero or zero, which is a little bit artificial, and then we'll see in a little bit. But this is how we use to do it mathematically. And then at that inflection point, we extrapolate that inflection point to the level of nutrient intake, and that's what we call the requirement. And therefore, we say that the requirement tends to be fairly close to the minimal amount of a nutrient that is needed to avoid the deficiency in pigs. We not only work with this type of response, we also work with this response where we can have a decreasing response. As nutrient intake increases, our response variable decreases. This is the example of the plasma urea nitrogen, or the indicator amino acid oxidation method, or the feed conversion ratio. If we're talking about amino acids, we can have combinations, whether we're using direct oxidation or direct oxidation in plasma or indirect oxidation. At the end of the day, if you look at these three graphs, they all mathematically look the same. We have a linear slope, and then we have a slope that has a value of zero, or this is a flat line. In reality, what's happening is that these responses are curvilinear. If we look at here the concentration of a nutrient or nutrient intake by a pig, if he's not consuming anything, well, the animal may die. As it increases the intake of that nutrient, it's still going to be in what we call a deficient status, and then the functions and the response are going to be highly compromised. As we increase furthermore the intake of that nutrient, then we're going to be in a marginally deficient state, and the animal, it's closer to be in a well-balanced and in a well nutrition status. Then as we increase more that level of nutrient, then we're going to have a wider optimal range. And then you can see that the shape of the curve here is more like an sigmoidal or like an S-type shape that we artificially tended to simplify mathematically using two straight lines. But then after the optimal range, if that intake of that nutrient continues to increase, then we're going to enter another marginal toxicity state. Eventually we can get to a toxic state, and eventually that can cause death. For most nutrients, the optimal range, it's pretty wide. For some nutrients is fairly narrow, and the narrowest that we know, it's selenium, and that's the main reason why its supplementation, it's fairly regulated in all countries around the world. If we look at the lysine requirement for pigs until about 140 kilograms of body weight, and this is information coming from the NRC. What we see here in the red line is that those requirement or that requirement of lysine increases as body weight increases, and it reaches a maximum of somewhere around 80 kilograms, and then it starts decreasing down. Why is the requirement decreasing? The requirement is decreasing because the amount of tissue, lean tissue being deposited or muscle mass being deposited, it's being reduced. If we look at the daily gain weight of a pig, then we can see sort of the same response, this type of quadratic response, very similar between the lysine requirement and the daily lean gain. Now, if we look at the way we formulate the diets and we look at feed intake, then we can see that as body weight increases, then feed intake increases quite drastically. And that is the reason why when we put that requirement corrected by that level of feed intake, we see that lysine as a percentage of the diet, the concentration of lysine in that diet, it's decreasing as the age increases. But as we can see on the graph on the left, that requirement of lysine continues to increase. But because the increase in feed intake is greater than the reduction of lysine need, then we have a reduction as a percent. So the concentration of lysine that is needed is less. Because we can dilute it more and provide the same amount of lysine in a bigger amount of feed. If we have situations where we see where feed intake is going to be compromised, then we can concentrate more, which means we use a greater percentage of that nutrient in the diet, with still the objective of delivering the same amount of that nutrient on a daily basis. Here we have an example of a nutrient determination. In this case, we're going to use lysine. So this is that typical curve that I was describing about, where we have in this particular case, because we're using the indicator oxidation method, we have a slope that is decreasing and until it reaches a break point, and then we have a plateau. With that break point in this case, it's indicated as 10.6 grams per kilogram. So that would be the requirement of lysine for this particular group of pigs. But let's think about that when these studies are run, they are not run with one pig or two pigs. They are run with several pigs. And at the end, when we make these determinations, we're talking about averages, and it's the average of a group of pigs. In this other graph, what we're looking at here is we're looking at the lysine requirement of individual pigs. So each point that you see here on the graph on the right, it's the lysine requirement of an individual pig. And long and behold, what do we get? We get a normal distribution or a bell-shaped curve. And the requirement in this case is expressed as 9.1, and that is the average. So it's important to keep in mind that the nutrient requirements are averages, and any other average or any average has a degree of variability that is associated. And if we remember the central limit theorem or the bell-shaped curve, then let's remember that plus minus 1 standard deviation away from the mean will be covering about 68% of the data. If we go 2 standard deviations, we're talking about roughly 95% of the data, and 3 standard deviations, we're talking about roughly 99% of the data. So up to a certain point, when we talk about a requirement that is given, for example, by the NRC, that is a number that is an average. And by definition, the average means that 50% of the pigs will be covered with that nutrient requirement, and the other 50% likely requires something greater than the number being expressed. The other thing that is very common in swine nutrition is to provide different feeding phases to the pigs. Why do we do this? We do this because the nutrient needs of the animal is changing. In this case, let's look at the black line is the lysine or percent of the diet as the pig increases in body weight. And the red line represents different diets. And in this case, this will be a 3-phase feeding diet. And I'm exaggerating things here for the point of illustration. What we have here is that at some point in time, or most of the time, we are going to have the animals, the pigs are going to be subjected to either excess of nutrients or deficiency of nutrients, because we cannot vary the concentration of nutrients in the diet on a daily basis, whereas the pig is growing on a daily basis. And therefore we enter in this conundrum, and like sometimes we're feeding more than that the pig need, and other days we're feeding less than what the pig need, and then there'll be maybe a day or two in this growth period where we are actually feeding exactly what the pig need. And this is the reason why we use several feeding phases, because as we increase the number of feeding phases, then we are starting to get closer and closer to that nutrient requirement line. Now, the bottom line here is, well, how many phases should I be feeding? The answer is as many as your system allows you to feed. As many diets as you can handle. It will be better for the animal. It will be better for the physiology of the animal. It will be better for the point of view of feed cost, and it will be better from the point of view of nutrient management of the waste and the amount of nutrients that are present in that manure that eventually we're going to have to manage. Let's talk about energy. Energy is the ability to do work like standing, walking, digestion, peristalsis, muscle contraction, lactation, reproduction, growth, all these things. Energy is not a nutrient, but is treated quantitatively like it is a nutrient. And you will hear nutritionists, we talk about energy and the amount of energy, and we even talk about energy needs and energy requirements. And energy, like a nutrient, can be digested, can be absorbed, can be partitioned, can be expended, and it can even be excreted out of the body. And we'll see that more in detail in the next slide. Energy is contained in the compounds that we feed to animals in feeds or the feedstuffs in the form of chemical energy. And this chemical energy is what we call gross energy. And we measure this gross energy by placing the ingredient or the feed in a calorimetric bomb, and we burn it, and then we quantify the amount of heat or any energy that is released during the burning process. That energy will be released as heat, and that's what we quantified, and we call it gross energy. This energy is released during metabolism and is needed for metabolic purposes. So we can release metabolism during glycolysis. We can produce energy in the citric acid cycle or in the Krebs cycle. We can generate energy using electron transport chains, like to generate ATP. And the uses of energy we can talk about in two main categories. We can talk about the use of energy for synthesis of proteins, fatty acids, glycogen, any other processes. And we can also use energy in certain metabolic processes that do require energy, like ion pumping. Certain absorption of nutrients, as we'll see in other talks, require the expenditure of energy for that nutrient to be uptaken. The energy system, it's defined as different definitions of the partitioning of the energy. So as we mentioned previously, gross energy of a particular ingredient is what we can measure in a calorimetric bomb when we burn that ingredient. If we feed this ingredient and then collect the feces and then burn those feces, then we're going to find out that there is certain amount of energy that was left on those feces. And then if we subtract the energy from the feces from the gross energy, we're going to obtain the digestible energy. If we do the same thing with the urine and collect the urine and measure the amount of energy in the urine and subtract that from the digestible energy, we are going to obtain the metabolizable energy. The next step will be to determine what is the heat increment, or how much heat is produced by a pig when it is metabolizing or when it's using a particular ingredient. We quantify that amount of heat and we subtract that amount of energy from metabolizable energy, and we're going to obtain net energy. And we can do a further partitioning of net energy, because we can talk about net energy for maintenance, or net energy for growth, or net energy for lactation, or other purposes. It is important here to remember that energy comes from three main sources, and those are lipids, carbohydrates, and amino acids. There is no other source of energy from other molecules that the pig can ingest or utilize in the metabolic process. Now, amino acids are very interesting molecules because their energy could be used in one of two forms. It could be used as oxidation, or energy that is actually expended to do metabolic processes, as is done with lipids or carbohydrates. And the other one is for protein synthesis. So energy from amino acids could be accumulated as protein synthesis, and the molecule itself, the amino acids by themselves, they have certain amount of energy, and we know the amount of energy for each particular amino acid. And that's why when we formulate the diets, and even when we use crystalline amino acids, we use a certain amount of amino acid, and we also assign a certain amount of energy value. Let's talk about diet and feed formulation. A diet is a mixture of feedstuffs of different ingredients that we use to supply nutrients to an animal. A ration is basically it's the sum of the water and the feed that a pig is going to consume in one day. And the ways to put it is the amount of each one of these ingredients that the pig is going to consume in one day, plus the amount of water that it will drink. What is formulation? When we talk about feed formulation, well, feed is the type of food that a organism consumes. When we're talking about animals, we tend to call the food that animals consume, we refer to as feed. And then this feed could be in one of the main categories that we have here. as concentrates, roughages or forages, and then supplements and additives. And what is formulation? Formulation, it's, in my opinion, it's a mathematical art of including various feedstuffs and combining in different ways to meet the needs of a pig on a daily basis. And it's an art because it has part of science and it has a very heavy mathematical component. On the other hand, we need to make sure that the feed that we're going to make, it's going to be palatable, that the pig is going to like it, it's going to eat it, and it's going to be able to digest it and extract the nutrition that we want out of that feed. And like we mentioned before, when we talk about nutrient requirements, we express them on a gram per day basis, and then we correct them by the intake of feed, and we determine the percentages or the concentration of each nutrient in a particular feed formulation. Let's briefly talk about the 2012 NRC calculator for nutrients. This is the main landing page for the swine nutrient calculator, which you can obtain for free from the National Research Council website. So the first thing that we need to do is we need to select the nutrient systems for energy, for amino acids, and for phosphorus. So for energy, whether we're going to talk about or work on digestible, metabolizable, or net energy. For amino acids, whether we're going to talk about on total amino acids or standardized ileal digestible amino acids. And for phosphorus, it's either available or standardized total tract digestible phosphorus. The next step is we select the group of pigs that we want to estimate nutrient requirements, and the four groups that this calculator provides are starting pigs up to 20 kilograms of body weight, grow finishing pigs from 20 to about 140 kilograms of body weight, gestating sows, and lactating sows. The main inputs that we need to provide to the calculator are, first and foremost, is the energy density of the diet. In this case, I selected to work on metabolizable energy, and therefore is asking for the amount of metabolizable energy. Because pigs tend to eat to fulfill their energy requirements, then this number is very important because it's going to determine feed intake and therefore the concentration or percentage of amino acids and nutrients in the diet, as we'll see how is it going to be adjusted. We need to determine what is the gender of the animals that we are working. Is it gilts and barrows? Is it intact males? Is it only gilts? Is it only barrows? Barrows are castrated males. Gilts are basically the females. It's also very important that this program is going to ask us what is the feed intake that we expect, or the feed consumption or the feed disappearance, and is asking us for basically for a wastage value. In this case, we're estimating that there's going to be about a 5% of wasted feed, and we need to take that into account because we need to formulate and make the adjustments based on what the animal is actually going to consume. There's also some environmental factors that we can consider about. We can talk about temperature, and we can consider about pig space. There's too many options, and we're not going to be able to cover all of them here. The next point that is very important is to select what is the regression curve, or what is the model that we want to use for whole body protein deposition, and is expressed on a grams per day basis. The calculator has several built-in patterns, and you are also able to use your own specific curves. After that, and it's not shown here in this screenshot, is to input the body weight range, and we'll see that in the next slide. And after that, we hit calculate, and then this calculator is going to provide us with the estimated nutrient needs. As I mentioned in the previous slide, here's where we will input the body weight range, and in this case we're talking about that we want to estimate the nutrient requirements for a pig population of 25 to 50 kilograms of body weight. So first, the program give us an output of values that we need to review these values very carefully. The first two numbers that we have is the body weight range that we input. So we input 25 to 50 kilograms, and the program, after it did its calculations, it's telling us that this is an estimate for pigs from 24.7 to 50.5 kilograms of body weight. So there is very close agreement. It will tell us what is the metabolizable energy value of the feed. That's the number that we inputted, and it gives us another outputs of different nutrients, as well as estimated feed intake and growth. The next section is the nutrient output, and here's where we're going to have the nutrient requirements, and we have three main columns here. The column in the center is the one that we need to look at first, and that is the true requirement. And that's the requirement in grams per day. So for example, lysine is at 14.8 grams of lysine per day. That's what we need to provide. We should be able to formulate the feed using 0.98% of lysine as long as our feed intake calculations are correct, and we'll see this here in a little bit. The other side, when we talk about the average mean body weight, because we're calculating the averages, the nutrient requirements for the average body weight. In this case, it's for a pig that has a body weight of 37.6. And that number comes in it's the average of the 24.7 and the 50.2. And this is also why, when I mentioned before, is like sometimes we'll be feeding excesses, sometimes we'll be feeding deficiencies, is because we're formulating or we're estimating the nutrient requirements of a 37.6 kilogram pig, not a 25 kilogram pig, not a 50 kilogram pig, not a 40 kilogram pig, not a 30 kilogram pig. Okay? The next number that we have here is this estimation of feed intake, and that comes, from the calculation of there is an estimate of how much metabolizable energy is going to be needed to deposit certain amount of lean tissue, and that amount of protein, which is this 4,961 kcals, it's divided by the 3,300 kcals in the diet that we estimate, and give us this value of a feed intake of 1.03 kilograms per day. That value, which is supposed to be consumed by the pig, is corrected by the waste value that we use, which is 5% waste. So if we take 1.503 and divide by 0.95, we obtain the value of 1.583, which is what this program is estimating that is going to be the amount of feed that we're going to estimate that these pigs are going to consume in average. Let's review some points that we have discussed thus far. What is the advantage of phase feeding? The main advantage is the proximity between the nutrient needs of the pig and the nutrient content of the diet. And the more phases we provide, the better we're going to be. Is energy a nutrient? No. Energy is not a nutrient. It's a quality of certain nutrients, mainly carbohydrates, lipids, and amino acids. But for quantitative purposes and for formulation purposes, we treat energy in the same way mathematically that we'll treat any of the other nutrients that are required by a pig. What is the main factor in determining nutrient requirements for pigs? It's the rate of lean tissue deposition, and it's very important that for every farm, a determination of the lean tissue deposition it's made so we can make accurate estimates of the nutrient needs of those pigs.